Assalamualaikum and welcome back. Now let's continue with the next example, which is item 3 here. Here we are asked to evaluate the integral by changing to polar coordinates. So here you can see that we have a double integral in Cartesian. So now we're going to evaluate this by first changing it to polar coordinates. The reason is it will be easier to evaluate. Okay, so if we look at the double integral as it is, you can see that this is very hard to evaluate because here we have e negative x squared, and then or you can change this to e negative x squared times e to the power of negative y squared, but still it's very hard to evaluate this as it is. So now we're going to change the double integral from Cartesian coordinates to polar coordinates. Right, to do that, we need to get the region of integration. So remember, the region of integration can be sketched by using the limits of the variables given. So here, the variables given is in Cartesian, so we can get the limits for x and the limits for y. Now let's get the limits for x. X is the one integrated last, so from the limits of x, we have two equations. Upper limit is x equals 1. The lower limit is x equals negative 1. Now the inner integral is integration with respect to y. So from the limits of y, we can get another two equations. So the first one, the upper limit is y equals square root of 1 minus x squared. And the lower limit, we have another equation, which is y equals 0. So from the four equations, we should be able to sketch our region of integration and then change it to polar. So it's going to be, our region is going to be part of a circle. All right, so let's sketch the four equations. All right, so we have y-axis, x-axis. So this is x-axis, y-axis. We have the first equation, x equals 1. That is just a straight line, vertical. Okay, vertical straight line. So let's say this is a 1. So this is x equals 1. And then we have x equals negative 1, another vertical line. Let's say this is x equals negative 1. So we have here we have x equals 1, here we have x negative 1, and we have y equals 0. We know y equals 0 is the x-axis. So we have we have y equals 0, which is the x-axis. Not very pretty there. Okay. Let me sketch that again. Okay, that is y equals 0. So we still have one more, which is y equals square root of negative x squared. So we know here from this, we know that this must be, y must be larger than or equal to 0, okay, because we have a positive root. But if you don't know the shape of it yet, we're going to do some mathematical manipulation. So from here, okay, we're going to get rid of the square root by squaring both sides. So we end up with this on the left, and on the right we have this. Okay, rewriting the equation, rearrange the equation, we get x squared plus y squared equals 1. And we know that this is an equation of a circle where the radius is 1 and the center is at the origin, 0, 0. Oh my goodness, hang on, 0, 0, radius is 1. Let me write it again. Okay, the radius is 1 and the center is at the origin. Okay, but you can also see that we can change this to polar coordinates. Remember, x squared plus y squared is r squared. So we have this, but then we can take the square root, then we get r equals 1. So another equation for x squared plus y squared, where we have a circle of radius 1 centering at 0, 0. So another equation for this is r equals 1. Okay, so we have r equals 1, a circle of radius 1 centering at 0, 0. But remember, our original limits for y is this. Y equals square root of 1 minus x squared where y must be larger than or equal to 0, which means we only consider the part of a circle where y is positive. Okay, so we have to remember the original limit, y is positive. So we're not taking the whole circle, we only take the circle where y is positive, which means that we only take the top half of the circle, or radius 1 centering at 0, 0. So we have this circle here. Alright, so we know now our region is this, because it has to be bounded by all 4 boundaries. Okay, so we have the 4 boundaries, the 4 equations here. Okay, alright, so now we can change the the Cartesian into polar coordinates. I'm gonna copy this. So we're gonna change the Cartesian into polar coordinates. Okay, so we have double integral. First we change the integrand. So the integrand e is still e. Oops. E is still e in polar. And then we have x squared plus y squared there. That should be replaced by r squared. So we have negative r squared. Okay, now remember dA here. dA, like this. So dA in Cartesian can be dy dx, or it can be dx dy. But in polar, dA is r dr d theta. Okay, so dy dx there is dA. Then in polar, dA will be replaced by r dr d theta. Okay, I hope that explains it. So dy dx is actually dA, but dA in polar is r dr d theta. Okay, now let's get the limits for theta and r. Okay, so first let's get the limits for theta. So remember, theta is measured from the positive x-axis. Okay, and then we draw like an angle from here, anti-clockwise direction. As you can see, it stops on the negative x-axis. So theta starts from the positive x-axis, which means theta is 0, and then it stops on the negative x-axis where theta is equal to pi. Okay, now let's get the limits for r. For r, we measure from the origin across your region. So you can do it this way, or you can do it this way, as long as it's in the region, provided that it starts from the origin. But you can see that the region covers the origin. So it starts at the origin and then it stops on the red circle. Okay, the red circle is governed by this equation. Okay, so it starts from the origin, then it stops on the red circle. So r, lower limit for r is 0, and it stops on the red circle where r is 1. Okay, so now we're gonna evaluate this. So that's how we get the limits for r and theta from Cartesian. Okay, now let's evaluate this. For double integral, we have to evaluate the inner integral first, which is this one. So we're going to integrate with respect to r, and here we're going to use substitution method. Okay, so we're going to let u as r squared, which means that du is going to be 2r dr, and here we have r dr, so that will be replaced by du over 2. Okay, so we have 0 to pi, and here we have e, negative r squared is replaced by u, so that will be u, and r dr is du over 2, and we still have d theta. Okay, now what I want to do is I'm going to use the limits for r to get the limits for u. Okay, the upper limit for r is 1. Okay, so when r is 1, r squared is also 1, so u is also 1, so the upper limit for u is also 1. The lower limit for r is 0, so when r is 0, 0 squared is also 0, so in this case the limits for r and u are the same. Okay, alright, now integrate the inner integral. We have e negative u over 2 divided by negative 1, so we have this. Okay, and then replace u with upper and lower limits. We still have d theta. Okay, so from here we get negative. If you don't like the negative bit, we can always write it outside of the value here. So we have e negative 1 minus e negative 0, which is really 1. Here we can write e negative 0. E negative 0 is really 1 over e to the power of 0, which is 1 over 1, which is 1. Okay, so from there we can write this down as negative, that's positive, so we have a half, minus 1 over 2e, or you can write e to the power of negative 1. So this is a constant. Now integrate that with respect to theta. So a half minus 1 over 2e, that's a constant. So you end up with e, and then we have theta. Theta from 0 to pi. So replacing theta with upper and lower limits, then we get pi 1 minus, a half minus 1 over 2e. Or you can factor a half out, then you have 1 minus 1 over e, or e to the power of negative 1. Okay, so that is how to change from Cartesian to polar. First, you get the limits for x and y, and then sketch your equations, the 4 equations. From there you can get your region. Then from the region you can see that your region usually is part of a circle, or the whole circles, or part of a cardioid, so it's easier to evaluate this by changing it to polar. Once you have your region, you can get the limits for r and theta, and of course the integrand here has to be changed in terms of x and y as well. So if you see x, change it to r cos theta, and you see y, change it to r sin theta, but we know x squared plus y squared is r squared. Okay, so the integrand should be in terms of r and theta, and then evaluate as usual, then you get your answer. That's it. Thank you.